Hello and welcome to another episode of Effective JaRu, the series where we read effective Java and try to port each item over to idiomatic Rust, if possible. So item 16 says that you should favor composition over inheritance. And it gives you plenty of examples. Gives you one particular example which shows that in the moment you want to be in control over your API and you want to be working the same way forever, that you basically cannot inherit from a superclass. Not unless that is specifically designed to be inherited from, so that you basically understand that there is a contract between your superclass and you, and your superclass says, I'm never going to change, never ever. And I'm never going to change my implementation details, ever. And things like that. So it's really, basically you're dependent then on your superclass, and this can break you in many ways. And, it doesn't have to happen, but it can happen, and things are inherently unsafe, or problematic. So I think the contrived example here is the instrumented hash set. The idea is that you want to count the additions to the hash set over the lifetime of the instance. And the problem here turned out to be that add-all is implemented by the superclass, so that it just calls itself its own add method, which then, in this case, leads to you counting twice the amount of things. You could obviously fix that by just not overriding this one anymore, but you can't know how this is implemented, right? This is an implementation detail, self calls. And you just don't know. So that's problematic. You can't really do it. Also, and that's actually I think that's that. And generally, if you want to be in control over your interface, you're supposed to forward it or have a forwarding interface set up, which basically means that you use composition instead of inheritance. Composition means that you own the item that you're interested in, and then implement the entire interface and just forward everything to the object. And this is what you see here. Super easy. It's just repetitive and boring. So you don't really want to do this, but maybe it could be interesting to see a few things about these generics here. So to array a generic one, does this look clean to you? No. I think this was the one that was used before they had generics, and this was then added so that generics are part of the equation. So yeah, it's super simple generics as well. It's really just like a type that you can replace, it seems. And type bounds you can have as well. This seems to be the I don't care about the type or type inference type inference character. And this is kind of a type bound, I think. And obviously you can at least say that this one should inherit the other. Or be the other. So yeah, that's that. So how would we do that? Oh yeah, we might even have a look at the instrumented set then, which extends the forwarding set, which it trusts, right? So it extends again, but this time it trusts that there's no special behavior because of the forwarding. So the good thing is that it can now just override what it wants to override and do the counting, and will definitely get it right forever. However, the disadvantage is that this set that is given here is given as a reference, right? So you do not own that set exclusively. So others can do stuff with it. They can mutate it. And that's a huge problem. So you're not safe again, right? And you should just refrain from using this set, but nobody will actually assure that. Not so in Rust, right? Not so in Rust. So we can have a look. We could try to get something like a forwarding set. I have no idea how that would be done. If in doubt, I mean, we are using composition anyway in Rust because there's no such thing as inheritance, which is a good thing once again, considering the complexity and the issues that arise from just that. I think considering that, you might just have our own instrumented set that just owns the set and just puts a few methods out of there. We might have a look at the hash set implementation just to see if there is some sort of trait that we could use. But I do not think so, which is cool actually. They didn't tradify that. The traits are just for standard operations. You usually have iterator conversions, bitwise, or you have indexed axis. Usually you can clone, but there's nothing else there that would make this a set, right? So if you want to take a set, you would have to specify that you want to take a set. There's no trait for this, which I personally don't mind. If you look at the set interface here in Java, then you kind of understand why I wouldn't mind having not such a blown up trait in Rust, because you do not have traits that look like this unless they are completely or automatically implemented for you. For instance, iterator. The iterator trait is huge because it has such a huge amount of utility functions, but these are all based on you providing a single one, which is next, which is what matters in the end, right? So the Rust version will look very, very different. I will just take the instrumented set here and get started here. So instrumented, give me a moment here. Instrumented set to get my, to warm up my fingers. What we have is an inner one. I usually call it inner. It's a hash set. Use std collections hash set. And yes, we want to own it. This is not a reference to anything. It's something we own. We could, of course, have a reference. We could make certain things work with allowing the client to keep ownership, and he just borrows it out to us for a while. We could obviously do that, but I say no. We would like to own it, then we use it, and then you can, for instance, convert ourselves back into the hash set that you came from, or into the hash set that we have been created with. So that is that. Impl instrumented. I have trouble writing instrumented for some reason. So instrumented set, and I think, not to forget, I guess it's about time to kind of get our testing started. Extern crate item 16, and then we want to use everything from item 16 and write our first test that says set forwarding set. Cool. So now we should be able to create our instrumented set. Let mat s be an instrumented set new that gets a hash set, right? So that's how we would do it. We don't even have that yet, but we will soon. Use std collections hash set. Oh, by the way, that's a generic type. So now we have to get into generics here. I think a hash set has two, right? It has a default one. Yeah, let's see how we do this. Let's see how that can work for us. I'm not sure if we can just keep this default random state thing. I don't think so. I think we have to mention it. So it's an std collections hash map random state. tr So it's tr. So here we have tr, and now at the latest we have to put on some type bounds, so that we are actually able to use it. I think at least for new we would need these type bounds. So that's also interesting. I have to think about this, because you obviously can have multiple implementations with different bounds, and these will only be available depending on what you have there. So usually what you want is to not specify. Yeah, I don't know. Let's try to get the new working first. So instrumented set tr. All right, and we have pub and new. That takes a set, that is a hash set of tr. I didn't specify the bounds yet, and that returns an instrumented set tr. There we go. And all that just to get the inner one initialized with our set here. And that could work, but I would really like to make the bounds, to set up the bounds, and maybe even to provide a standard here. And how does that work? So you specify it here and say this should be a random state. So let's get this. I hope we can import this here. We will see. And I would like to let type inference do all the nasty work. And we will just, oh look, now stuff fails. Let's see. So type inference here will not have enough information to do anything, that's for sure. Might as well do this. Oh, cargo test unit. So, oh wow, what the heck am I doing? And I didn't even see that. Random state doesn't seem to be there. All right, so it's in hash map then. Use std collections hash map random state, right? Okay, so now we can say this should be random state by default. I don't know if we have to repeat that here. Hopefully not. We should put the type bounds there, because otherwise I think we can't even do this. Yeah, we need this. We need these type bounds. And I would actually be interested in seeing how this is specified here. So that is that. The bound it needs is here. And then t is hash plus equality. This is something we need as well. So it has one implementation for the default random state, and it has one implementation for the totally generic one where nothing is known. And I wonder if you have to do it similarly to make this work, which could very well be. But in any case, this is kind of what we want. Use std collections, std hash, is this existing? Use std, is this also existing? Apparently so. Nice. Yeah. Where t, oh look, s is the hash state. Yeah, so let's go with these as well. Now it's still easy to change. So that's the most complex part here, getting the generics right. That's how it seems. Oh yeah, and hash state we have to get from somewhere. Hash state. So the default should be random state, right? And we are implementing it generically over every s, which is a hash state, which should include the random state there. Oh, hash state is not there. Where is it coming from? Show me. Hash. Where is this coming from? It's coming from collections hash state. Okay. Once again, no luck. Use std collections hash state. There we go. Okay, that's a bit better. So this could already work if we are lucky, but we will see how this works in the moment we try to use it. So use a unstable library feature std misc. Ha! Ha 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 ha! Hash stuff is unclear. Oh man. Yeah, this can happen. And now we run into it. So now we have to switch to Rust nightly. And mark this. Basically say, well, feature std misc here. It should tell you somewhere what you have to do to make this work. No, it doesn't. I thought it does, but maybe let's try to build it. Let's try to build it again. And here, yeah, that's nightly now, and it tells you exactly what you want to do. And as you can see, this changed now because that's a later version of Rust, and they kind of got more specific with their features. Hash map hasher. So this one we now have to specify here in order to bring in that feature. This is a way to protect against changes and make clear that we are now using something that is unstable. And it's kind of our signature, right? Cool, so that works so far. Let's see if we can get one going here. And I'd also want to add have a function here that allows me to add something to the hash set. So fn add, I will just mirror this implementation here, even though we will return an option of t, huh? So we need to be mutable, mut self, and we need to get an item of type t. We want to own this, obviously, because that's going to be moved exclusively into our inner hash set. And yeah, we return whatever was there, so this should just be what we get if we try to insert it into our inner item. So that should be all we need to implement this. And now the cool thing is we are able to say s add assert s add. What do we want to insert? Do we want to insert strings? Why not? S insert foo is none. That should be true. And that should also work. Let's see. Oh. Really? Well, if it inserts booleans, or if it returns booleans here, then we shall do the same. I think a map returns what was there before. Wait, really? Okay, boolean. Interesting. True, if it hashes to the same thing, it's supposed to be the same object, so it doesn't have to return the object, right? Booleans are enough in that case. So yes, I think that makes sense. So is false because or true because it added it, right? I think this is what it is. If not, we will see in a moment. Cool, so far so good. So we have our interface already, and that's that, right? And we want to count stuff as well. So we need a counter here, add count, which is a usize, right? Because we can add as many items as we can handle with our standard platform's maximum word size, which is 32-bit on a 32-bit system. Good. So yeah, what we do is, once we have, well, I think we count before, self add count plus equals 1, And of course we want to initialize this with the 0. And we are good. That's all we need. And now we could also do add all, obviously. Pub fn, which takes some iterator. We can do this actually just for the fun of it, because you know, add all wants a collection here, which is, I think, a basic interface for array types. But yeah, let's see what it really is. But in Rust, we would use an iterator type, which is, I think, even less than a collection, because all it knows is that you can iterate over a sequence of items, and you have no idea, and especially no random access to this. So let's see what a collection is. Java collection interface. The collection interface. All right, here. That's probably what we want. All sub interfaces iterable. Okay, so that is really even the base of iterable. What can it do? So, okay, here are the methods, instance methods. So add all. Wow, so that's mutable by default. Jesus Christ. Clear, contains, equals. Excuse me. Iterator. Okay, so that basically says that, gee, that's a huge thing. So it requires a backing. This is not a streamable interface, I think, because in the moment you ask for something like contains all, you will consume your iterator, which you obviously didn't have. So the iterator probably is what is an iterator. See, next, removes from the underlying collection the last element returned by this iterator. And it's an optional operation, and you have no idea if that even does anything. Gee whiz, whatever. Who designs that? I don't know. So it seems so spotty to me if you just look at it. I don't know if that is really what you want. Actually, I don't want that. But anyway, here we go. Let's try to do it the Rust way. So we want to have an iterator over anything, and we want to be really nice. So we want to be able to. Oh yeah, actually one more thing. Let's return pub add count. Let's return that, shall we? Because why don't we count it if we don't return anything, or if we are not able to provide that information? Self add count. There we go. Pub add all. I really just mirrored this without thinking about, well, maybe, you know, if this is add all, add either, add all. Yeah, I think add all is okay. It's also nice and short. So mod self. And we have an iterator. What do we return? I think now return nothing, actually. Of course, we have to specify I, where I is into iterator with an item of type T. So you want an iterator that spits out items that have the desired type, right? And into iterator is a conversion trait which allows us to get an iterator. We could also, I think, do it like this, which is more modern, even in Rust, because the into conversion trait is what you usually want to have, right? Into iterator. And the into iterator thing was something that was used previously, and I think they're now kind of interoperable. You can use one or the other and it doesn't matter, even though technically you only want to use these conversion traits now. So that is that. For item in it into self inner insert item. Oh, yeah, sure. And we wanna own these. So into how do I specify? Let's see. This could not work because we need to own this stuff. And the iterator might just give us stuff that we do not own. We want to drain this iterator. Yeah, let's see. Iterator. Yeah, that was expected, but can I drain you? Can I drain you? Or get some mutable stuff out of there? Yeah, let's see. I might explicitly ask for a draining iterator. We could also say that T must have clone for this to work, because then we could just clone it in and not consume the iterator. But I think this might actually not work for us. So let's first check that we get the add count right. So add count should now be 1, whereas previously it should of course have been 0. Let's see. Probably it doesn't compile now. Yep. Yeah. So we have to, I think, also enforce that T is sized, right? And I wonder how we would do this best. We could have another impl declaration here, or impl scope, and then change stuff around there. We would, yeah, that's something we could do. So that's always interesting when you get the problem that the compiler doesn't know. Yeah, doesn't have enough information anymore. So if it's unsized, then this means that it really doesn't know does not have a constant size known in compile time. This is really it. And I wonder why that would be, right? Because we get, yeah, I think this is why you use into iterator, because now we would have to abstract over iterator as well. That's the problem, because this is a trait, and this is indeed not a constant size, but into iterator will fix that for us, right? I think this is why you do this. This makes it easier. Into iter. So let's see if that is better. Yeah. Wow. Let's see if we can even use it. I don't think so, but the problem is the consuming nature of this. Even though here it would be fine because we pass, well, would it be fine? I think it would be fine, but let's try. Foo. Oh, actually, yeah, we want to count only. We want to count this, right? So we want to count only if it was inserted. If it was actually inserted. So if this was inserted, then added and return true. Otherwise, return false. And here we do the same thing. If it was inserted, I'm very specific here. I know that you wouldn't have to do this, but I kind of like it right now. Then we say self add count plus equals 1. So that's interesting now, because now if we have a duplicate here, foo bar, then we would assume, yeah, there's nothing that we would expect here. Then you would assume that the add count is 2 in total, right? So it depends on how you define add count, the calls to add or the times it was actually added. Oh yeah, sure. We have to slice it, so that returns a slice to that thing. Excuse me. That, I mean, into iterator. Oh, now I get it. Actually, we don't have to slice it at all. We have to call the right function. What about that? Okay. Iterator is not implemented. We could call either, or we could just provide it with a slice, which will work for us, will work better. Okay, and now it gets interesting. It wants a string, it wants a string slice here, and it found a string. I think what happens is that this iterator is actually an iterator over shared string slices here. So we have, well, a borrow of a string. Even though this kind of doesn't really reveal what's happening. This is just related to us being on a totally read-only array here and handing out an iterator that doesn't really do the job. I think what would work is if we would create a vector here and then give it a draining iterator. I'm not sure if drain is... Oh. Let's say, oh no, wait. I think this might already work, but let's see. See? Because that really converts into an iterator that is consuming. It's kind of implicit, but there happen all these, all these conversions happen. And I guess you just have to train it and practice it. But at some point you get some sort of intuition for how this stuff works. So yeah, this is how you would do it. But this also means that you would have trouble to do this, just because you need something that owns or that an iterator that drains the items, right? That can own the item and change ownership so that you can add ownership to the actual set. I don't know if there's some sort of insert all in the set implementation, but I actually do not think so. Insert multiple iterator, nope. We have the from iterator trait implemented. So we could use an iterator to create a new hash set, and then I don't know if you can add hash sets to each other. Draining iterator. Yeah, anyway, I think that's sufficiently well done. And as you can see, this even works. So that would be the implementation in Rust. And just because of the generics, it gets a bit more visually confusing, I'd say. But only because of that. And this is, of course, something you get used to. I still don't know how to format this nicely, man. Gee, maybe like this, it's even better. Yeah, kind of. All right. But I like this more because you can only use composition. You kind of can do it right from the very beginning. We are truly generic here. We support everything the hash set supports. And that's just what you would want. And as you can see, type inference does a great job still. We never have to specify the type anywhere. It just is implied by the first time we add something. And that's quite amazing, I think. I love it. Cool. That should be this session. Thanks for watching and have a great day.